Welcome back. Today we're going to be doing a review of translating verbal phrases and algebraic expressions, which is what we looked at yesterday. So if you haven't done yesterday's lesson, make sure you go back and complete that one before you try today's. We're going to do a little couple of activities where we look at some verbal phrases and try to translate them into a variable expression or an algebraic expression. So we're going to do these together. If you want to pause and see if you can write them down on a piece of paper and see if you get them right, that's certainly up to you. So the first one says the sum of a number y and 20. So whenever I look at these, I'm going to be looking at my keywords. Remember, we have to look for keywords. So we know that when we see the sum of a number, that means we have to, hopefully you said add. So let's go ahead and look at number 2 and number 3, and then we'll make sure that we're correct. This one says 6 more. So hopefully you've clued into the fact that that one is an addition problem. But then let's keep reading, because here's when it gets hard. So we're adding 6 to something, but that we're adding 6 to twice a number, which is y. So if I said twice a number, which is y, wouldn't you take y and multiply it by 2? So it's going to look something like this. So we have 6 more than twice a number, which is y. So we're going to argue that ours is 2y plus 6, or 6 plus 2y. Let's go back and do this one. The sum means we're adding of a number, which is y, and 20. So I'm going to say it's going to look something like this. And let's do number 3. It says the difference. So the difference means that we're going to subtract. We're going to find the difference between 8 and a number, which is y. And you do have to be very careful when you're finding the difference, because we know that the order in which you put your numbers in a subtraction problem does matter. So we're going to find the difference between 8 and a number, which is y. So let's check our work and see if we are correct. So we said that this one was y plus 20, which is correct. Let's look at the next one. 2y, so twice the number y, plus 6, which is what we said over here. And then this one says 8 minus y. Okay, so let's go on and do some additional examples. Let's do 4, 5, and 6. So number 4 says 9 divided by, that was easy, a number, which is y. So I'm going to say that my problem might look something like this. 9 divided by y. And also remember that you might also see it written in fraction form. So 9 over y. Let's go on and look at number 5 before we check our answers. Product, the product of a number, which is y, and 20. We know that product means that we're going to be multiplying. And the two things that we're multiplying here are y and 20. So there's lots of different ways that this one can be written. The most common is going to be 20 with a y beside it. So a coefficient of 20 with my variable of y. And then, of course, my last one is one of those tricky subtraction ones. So it's 2 less than a number. And subtraction order does matter. So I want 2 less than whatever my number is, which means I'm going to start with my variable of y. And if I do 2 less than that, then that means I'm going to take away 2 to get 2 less than whatever my number was. So let's check and see if our answers are correct. We said it was 9 divided by y, which is exactly what they have written here, which is in fraction form. And then we said 20y, which is what they have as their answer. And then the last one, let's see if we got this one right. Y minus 2. Very good. Good work. Let's do some additional examples. I want to show you some where you're going to see some more difficult examples. So let's take a look at some of these. These get a little bit more tricky because you have a lot of expressions that are similar in nature. So let's take a look at this one. It says m less than a number. M less than a number. So we know that less than means we're going to subtract. And if we want m less than that number, then that means we're going to start with the number and take m away from that. So that means we're going to start with 8. And we're going to take m away from that 8. The next one says the quotient, and we know that quotient means to divide. So we're looking for something that divides m and 8. So m is divided by 8 in this particular case, and lucky for us, we have a fraction m over 8. The next one says 8 times a number. That one should be very easy for you. 8 times a number, which is m. So it's going to look something like this. And then the last one is a little bit more tricky. We have 8 more than, so that means that we're going to be adding something. But here's where it gets tricky. We have more than one thing. The cube of a number. And we know that the cube of a number means that we take that number and we raise it to the power of 3. So we're looking for one that says 8 plus m with a power of 3. So you look here, this one has m with a power of 3, but it's not adding 8. This one has a power of 3, but it's not adding 8. And if we keep looking, we finally found it, and it looks something like this. So one last thing that we're going to look at today is some real-world examples of how algebraic expressions can be expressed. So all of these are very similar in nature, and we're going to see if we can figure out which ones go where and why. So again, we're going to be looking for those key words. So the first one says the cost of Elizabeth's party will be divided by 12. Well, that one is pretty easy because you've got divided by 12. So we know that one we're going to be looking for a division. So if you look at our answer choices over here, the cost of Elizabeth's party, we don't know what it is. So we're just going to use a variable to represent the cost of her party. And you'll notice that the variable in all of my examples is an n, which is a very common variable to use. That cost is going to be divided by 12. So that means it's going to be this one because the cost of her party we do not know, but we do know that she's going to divide it by 12. Let's look at the next example. It says Jacob lost $12. If you lose money, hopefully you understand that that means your money's going away, which in mathematical terms means that we are subtracting. So he started with n amount of money. We don't know what amount of money he started with, but they're going to be subtracting $12 from that because he lost it. The next one says AJ earned $12 for his allowance this week. Well, if you earn money, that means you're making money, which means the amount of money that you had is growing or gaining, which in mathematical terms means addition. So we don't know how much money AJ started with, so we'll use the variable n for that. And since his money is growing because he earned money, that means this would be the term that we would match up with that. Cameron earns $12 per hour. Here's the key word, per. If Cameron works 1 hour, he's going to make $12. If Cameron works 2 hours, he's going to make $12 the first hour and $12 the second hour, which means 12 plus 12 is 24. So you could do repeated addition for every hour that he works, but we all know that the quick and easy way to do repeated addition is multiplication. So he's going to work n number of hours, and he's going to make $12 for each hour that he works. The last one says lunch costed $12. So this time we know what we're starting with, but we don't know how many people there were at lunch, but they're all going to split the cost equally. So if n number of people are going to split the cost. Split, you should recognize as a division. Then we know that we're starting with $12 and we're going to split that cost by n number of people. So I hope that this has been a meaningful lesson for you, a good review of how you can use verbal phrases and how you can translate them to algebraic expressions. Feel free to rewatch the video if you need to.